Question 4. So, completing the square. So we've got to kick off by only having a single x squared to factorise. So we take 2 outside the bracket and halve each of these terms, 49 over 2 being the third term. Now, focusing in on the first 2 terms, to complete the square we halve the coefficient of the x. So we halve this minus 10, giving us minus 5. So we have x minus 5 all squared. Now picture multiplying out that pair of brackets, you would have plus 25 on the end. We don't want the plus 25, so we must minus 25. These two terms here are therefore equal to this, which we've replaced it with. We still have the 49 over 2. So gather up together these last 2 terms. So this is minus 50 over 2, plus 49 over 2 is minus 1 over 2. And then multiply both these bits by the 2. So we get 2 lots of x minus 5 all squared, 2 lots of minus a half, which is minus 1. So that is our final answer to part 1. Now for part 2, and this really is the strength of this rearrangement, is this allows us to work out the minimum point. So if you imagine y equaling all of this, well, that's exactly what we're saying for part 2. Y is equaling this, so y equals this. So to minimize the y coordinate, we need to make this term as small as possible, and the smallest this can be, given we're squaring it, is 0. 2 lots of 0 and 0. So what must x be to make this bracket 0? Well, x must be 5. This minimises y because this first term is then 0. Now, what y value do we get when we've made x equal 5? Well, this term goes, that's 0, but we're still left with the minus 1, so minus 1. So the minimum point, the vertex of the curve, which is the minimum, is 5 minus 1.